In this session, I am going to explain SN1 and SN2 reactions. What is the meaning of first of all SN1 and SN2 reactions? In case of the SN1 reactions, those are called as unimolecular. In the name itself, one is there, that is unimolecular. Means molecularity is one. Then the meaning is molecularity is one, or else order is one. And unimolecular N, what is N here? N is nucleophilic. Nucleophilic. And S is substitution reactions. Substitution reactions. So unimolecular nucleophilic substitution reactions. Whereas coming to the SN2 reactions, 2 represents bimolecular. Bimolecular means molecularity is 2. Molecularity is 2 as well as order also 2. And nucleophilic, anyway we are calling this as the nucleophilic reactions. And substitute, S means S represents substitution reactions. And here in these SN1 and SN2 reactions, we are having certain terms that I will be explaining now. What are those terms are? And first we will be going to the reactants. We know reactants, they will be giving to the products. Reactants, they are giving to the products. In any reaction, reactants are giving to the products. This I will explain. And the next one is, what are the intermediates that are formed? Intermediates that are formed. And one more I will explain, that is those are the types of the solvents. Types of the solvents. Okay, this one about solvents, types of the solvents. And now what I am going to explain is reactants gives rise to products. What are the meaning of the reactants? In these reactants we are having two terms. Those are the reactants means substrate will be there, substrate as well as reagent. Substrate as well as a reagent, both are called as the reactants. What is the meaning of the substrate? Means which is the substance, the substance which is being attacked. The substance which is being attacked, so on which we are doing the reaction, that is the meaning, which is being attacked. This is a substrate. And whereas reagent means the substance which is going and attacking. The substance which goes and attack. Which goes and attack. So these are the two, both substance and reagent, both are called as the both are called as the both are called as the reactant. Substrate and the reagent, both are called as the reactants. And next one is, here what is the substrate in this nucleophilic reagent, nucleophilic substitution reactions? What is the substrate? Substrate is here, substrate is the alkyl halides. Alkyl halides are the substrates. Okay, and then haloarenes also. Haloarenes means haloalkenes and haloarenes. These are the substrates. Next one is, what is the reagent? In here the reagents are of two types: electrophilic reagents and nucleophilic reagent. Electrophile and nucleophile. Nu minus or else E minus we will call, because these are E plus electrophiles. If you come to electrophiles, these are electron deficient species. These are the electron deficient species. Electron deficient. Whereas if you come to Nu minus, these are electron rich species. Electron rich. That's why electron rich species. That's why they will, means the name itself, nucleophile is there. Nucleophile. Phile means which loves. or which seeks the nucleus. So they are electron rich, that's why they are seeking the nucleus here. They are loving the nucleus. That's why those are called as the nucleophiles. And in our yes, substitution reactions and all, now here we are mainly concentrating on nucleophilic uh, electron rich species are nucleophiles. Give the examples of what are the examples of the nucleophiles are OH minus. This is the main what we are now what we are using is this OH minus we are using. Or else we can use SH in place of oxygen thio. If you write thio alcohols, even those also we can use. Or else H2O. H2O here also oxygen is having electron rich. So even but now what we are using in the substitution reactions is OH minus. These are the nucleophiles. So we are mainly concentrating on the nucleophiles and we are mainly concentrating on the alkyl halides. And next one, if you come to this one, intermediates. What are the intermediates here? Intermediates here are, we are having two types of the intermediates. The intermediates are, this one is carbo C plus. If you come to this is this carbocation, carbocation, and we can have another intermediate that is C minus carboanion, or else we have C dot. This is carbon free radical, carbon free radical, and again we can have the transition state, the transition state. Now here in our substitution SN1 and SN2 reactions, what we are using mainly is these we are using. What are those? Carbocation, this one carbocation, and as well as the transition state. And these two we are means we will be come acrossing with this carbocation and the transition state. Next one is types of the solvents. Now I will go and explain what are the types of the solvents. Yes, coming to the types of the solvents, what are the two types here? Mainly we are having two types of the solvents. The first one is protic solvents, polar solvents, and non-polar solvents. One is the polar solvents and another one is the non-polar solvents. Non-polar solvents. And in this case of polar solvents, first let me explain non-polar solvents. Non-polar solvents, those are just like benzene, or else hexane, benzene, or else hexane. Okay, this is a normal straight chain, hexane and hexane, or else cyclohexane, means without any ring we will be drawing, that is the cyclohexane. Okay, those three means these are the little bit examples. Next one, here we are mainly concentrating on the polar solvents. Polar solvents, here in our SN1 and SN2 reactions we have been come across with these solvents. Those are polar solvents. Here again in the polar solvents we are having two types: polar protic solvents, polar protic solvents, as well as polar aprotic solvents, polar aprotic solvents. Polar aprotic. As coming to the polar protic solvents, and in this polar protic solvents we have, means what is the meaning of the, first of all, what is the meaning of polar protic solvents? The solvents which can give H plus ions, those are called as the polar protic solvents. And in the polar protic solvents, H2O, okay, if you take H2O, here H and hydrogen, due to the electronegativity difference here, they can release partial negative charge and the partial positive charge. They can easily give the H plus ions. Easily give H plus ions. These are the and one more is CH3COOH. Even this also we will take. But now here what we are taking is the polar, in case of SN1 reactions, here H2O we are taking. In case of SN2, polar aprotic solvents. What are polar aprotic solvents means? We will be going to acetone mainly. CH3CO CH3. This is the acetone. Acetone, if you go to acetone, it will not give the H plus ions in the solution. And one more is CH, in place of carbon I am writing sulfur here. CH3S double bond O CH3. Okay, this is called as sulfoxide. So, okay, sulf MSSO, sulfoxide. And one more we can take, that is DMA, DMA, DMA and DMF, DMF. DMF means dimethyl formamide, dimethyl formamide. And in case of DMA, dimethyl acetamide, dimethyl acetamide, dimethyl acetamide, dimethyl acetamide. I will draw the structures also. Here if you come to dimethyl acetamide, the structure is like this. CH3 C double bond O N, dimethyl na, so CON, actually we know CONH2 group, CONH2 group, this is the acetamide group. So in place of hydrogens H and H, we are replacing the methyl groups. So dimethyl. And CH3CO group is the acetamide, acetyl group. So yes, entire thing we will be calling as dimethyl acetamide. And if you come to here, dimethyl formamide means HCO. This is a formamide. And anyway it is connected to the dimethyl group. So this is the dimethyl formamide. So these are the polar aprotic solvents. Polar aprotic solvents. Next one we will be going to the what is the mechanism of the SN1 and SN2 reactions. Let me explain what are the types of the solvents here. Polar protic solvents and polar aprotic solvents. Polar protic solvents means which can give the H plus ions in the solution. And polar aprotic solvents means which cannot give H plus ions, cannot give H plus ions in the solution. Those are the polar aprotic solvent. Example acetone, and this one is, and with a dimethyl sulfoxide here. Sulfoxide we are writing. And next one is DMA, DMF, dimethyl formamide, dimethyl acetamide. So you first of all you keep in mind PP, polar protic solvents, and these are polar aprotic solvents. In polar protic solvents we are having water and CH3COOH. And regarding non-polar solvents, I told you already benzene, N-hexane and cyclohexane. Now these are not important in case of SN1 and SN2 reactions. Only the polar protic and polar non-protic solvent, those only we have to be in mind. We have to keep it in mind. And the nucleophiles, I told OH minus, Cn minus, H2O, and all these are the nucleophiles. I told you already what are the nucleophiles. Examples OH minus, and again Cn minus also we can keep, Cn minus H2. But mainly we are doing the OH minus. Okay, now let me explain the SN2 mechanism. Or else we will be going to the SN1. Okay, first of all we will be taking the SN1 mechanism. In case of the SN1 mechanism, here we are taking a chiral carbon atom. What is the meaning of the chiral carbon atom means? It is attached to the three different groups. means all the four are the different ones. Anyhow, this is the alkyl halide, and one is R and another is H. Again one more we can take R dash, one more alkyl group we can take. Okay, like this I have taken. This is called as the chiral carbon atom. What is the meaning of the chiral carbon atom? Is the carbon atom which is attached to four different groups, which is attached to four different groups. This is the chiral carbon, a compound having the chiral carbon atom we have taken four different groups. Next one, I told you already, alkyl halides we are taking in the SN1 and SN2 reactions, and the nucleophiles are also we are taking. And here the nucleophile is OH minus ion. OH minus ion, that is the nucleophile we are taking. And now what is the product that is formed? Means how OH minus is coming and attacking the alkyl halide. And during the reaction I told this is the reagent and this is the substrate, and in the middle intermediate is formed. And what is the intermediate here? The intermediate here is the carbocation. Here, because of the electronegative difference here, the electron pair is moved towards the X minus, and carbon, this in the middle central chiral carbon atom, is getting the partial positive charge. Now here it will be having the shape of like this, like a trigonal shape. We are coming across with a trigonal shape. And before we are having sp3 hybridization here. This is the sp3 hybridization. sp3 because it is attached to four different groups, and this carbon atom is attached to the three different groups. So sp3 is being converted to the sp2 here. Now OH, this is intermediate I told. Now OH minus is coming and attacking. Now we are getting a compound, that is, here we will get a racemic mixture we are getting. What is the meaning of the racemic mixture? Racemic mixture we are getting, and I will write here racemic mixture. Here if you come to this one, it is like a trigonal shape. So, and it is having a vacant orbital like this. So here it may attack from means from the top side it may attack, or else it may attack from the bottom side. So we are getting two types of the products. If the top side it is attacking, here this triangle like a trigonal shape is there, no, it is moving like this it is moving. And because these three groups like in a U shape they are like in a U shape they are coming here, and this OH minus is attacking like this. And one more product, if the OH group is attacking from another side, if it is attacking, now this shape it is like this, means the three bonds like this they are attacked, they are bonded, and OH minus is coming and attacking in this side. So we are getting two types of the products, means one is like the just like one umbrella, and another is like the tilted umbrella, like this we are getting. So I will draw the structures here, R and R dash H. Okay, connected to the carbon, and now we got the product OH, because H plus X minus is last in the first step, and in the second step here we are getting this one. And one more product, that is I am drawing in this structure, in this way I am drawing. First in this way we have drawn, now here in this way I am drawing, and C and R dash H and OH. So here two types, one is the dextroform, means just like the mirror images, and another is the lever form. We know the meaning of dextroform and lever form, which rotates the plane polarized light. plane polarized light to the clockwise direction. This is called as the dextro. Means the domains in the light they are having like this. First they are having. And when this plane polarized is passed to the dextro compound, it will rotate the domains in the clockwise direction. So it is a dextro compound. And if it is rotating the compounds in anti-clockwise direction, and this is like this, it is rotating, and another one like this, you should rotate. So I will draw like this. I will draw. This is the anti-clockwise. Okay, and these compounds are called as the LEVO compounds. So dextran. So we are getting a mixture of D and L. D and L. So it is called as a racemic mixture. Racemic mixture. Equal amounts of D and equal amounts of L we are getting. So this is called as a complete racemization. Complete racemization is taking place here. This is about the SN2 reactions, SN1 reactions. As coming to the SN2 reactions, how the SN2 reactions are going to be. What is the mechanism of the SN2 reactions? And in the SN2 reactions, here again I will take the same compound like this only, R dash, H and alkyl halide, and OH minus is attacked. Okay. Now here what is going to happen is an intermediate step, because here the nucleophile is strong nucleophile. This is the strong nucleophile here. This is the strong nucleophile. So before leaving strong nucleophile, before leaving the X, means see here, see R, okay, R dash, and then H is there. Here X minus is leaving, just like that it is leaving. At the same time OH minus is coming and attacking here. So this is having high energy, and it is said to be a transient stage. Transient means which exists for few minutes, which exists for fraction of the second only it exists, because it is highly energetic one. So it is said to be transient one. Fraction of the second only it will be existing, and this intermediate it gives back the product. How it is giving the product? So OHC here R, okay, R, and again H, again R dash, and OH minus. This is called as what? In the opposite side, of X minus, the opposite side of the X minus, OH minus attacks. This is called as inversion product. This is the inversion product. So here inversion product is formed. But whereas in case of this SN1 reactions, we have both the products. This is called as a retention. So this is the retention here. Means in the same side, here we are having, in the place of X minus we are having OH, that is a retention, and in the opposite side we are having, this is called as a inversion. So both the products, retention and inversion products, we are getting in case of SN1 reaction, whereas in case of the SN2 reactions we are getting only the inversion products, and which alkyl halides. If we come to tertiary alkyl halide, secondary alkyl halide, and primary alkyl halide, we know the meaning of tertiary alkyl halide. Carbon group attached to 3 other carbon atoms, this is called as a tertiary. When the carbon group is attached to 2 other carbon atoms, means one more is definitely a hydrogen atom, secondary. And if the carbon atom is attached to 3 other carbon atoms like the CH3Cl, okay, now this is the primary. And here these three, if you come to primary, secondary and tertiary, SN1 reactions, here tertiary, the rate of the reaction is more for tertiary rather than secondary rather than primary, because tertiary carbonium ion is always more stable. Tertiary carbonium ion is more stable, so we are getting the tertiary first. Whereas in case of SN2 reactions, here OH minus ion, I told you already, OH minus ion, it is OH minus ion in a transition state, it is coming in a transition state. So when OH minus ion is getting and attacked here, only less bulky groups are preferred here, less bulky groups, because in opposite side it is coming and attacking opposite side of the X minus to get the inversion product. So less bulky group is preferred. So primary alkyl groups have more rate of reaction than the secondary and than the tertiary. And regarding nucleophiles, here OH minus, here nucleophile is a strong nucleophile. In case of SN1 reactions, it is a strong nucleophile. So whenever the strong nucleophile is coming and attacking the alkyl halide, X minus is leaving. So here two steps are formed. Here in case of the SN1 reactions, the nucleophiles are weak nucleophiles. These are the weak nucleophiles. That is the major difference here in case of SN1 and SN2 reactions. Okay children, I think you are all got the points clear regarding SN1 and SN2 reactions. Okay, thank you children.